So here is paper 1 from the end of year test, and this is the first video where I go through the so-called easy questions. The easy ones I consider to be questions 1, 2 and 4, and there are a total of 15 marks, which means that if you do all of those perfectly right, then you are already passed. You have a grade 2. And let's just dive right into it. So question 1 says consider two functions where the function g has a constant that we don't know. And question A tells us to write down an expression for this g after f function of x. I've seen people that read this little circle as a multiplication, which is like very unfortunate because then you don't get anywhere with this question. So the little circle means that we are composing the two functions using g after the function f. So for question A, what we want to do is say that g after f in x means that we are taking g not on x, but on f of x, whatever that is. So if we put in f of x, then we take g to x minus 4. And then we just take the expression for g of x and we replace the x by x minus 4. And what we get is x minus 4 squared. We need a bracket because it has two terms that we want to square, plus k squared. And that's actually perfectly fit for an answer. There are some people who do this and then they think we need to expand the bracket, but that's actually a waste of time, plus it makes the next question even harder. Wow, the next question isn't very hard, but it makes it harder to solve. So don't do that, just leave it like this. This is an expression for g after f. Question B says that now we are given that g after f taken to 3 equals 10. And that means that now we replace x by 3 in this function that we have right above. So that just means that 3 minus 4 squared plus k squared, we're being told that this equals 10, and they want us to find the possible values of k. Well, 3 minus 4, that's minus 1, and then we square the result. So minus 1 squared, that is 1, plus k squared is 10, and we subtract 1 on both sides, so k squared is 9, which means that k is plus or minus 3. And we are done. Such a nice little startup question. Let's move on. Question 2 is probability theory. We have events A and B, and we try to call all our knowledge about probability theory. And we are given the probability of A and the probability of B and the probability of their intersection. So it's a good idea to visualize that A is an event and B is an event inside some probability space, or sample space as we call it. Just to get our brains thinking in the right direction. And they want first to calculate the probability of the union, A union B. So for that, we know the whole probability of A. That's sort of this, you can think in terms of the Venn diagram, that we know the size of A, and that's 0.55. And the size of B is 0.75, and in fact the intersection is pretty large, it's 0.5. So obviously we can't just add the probabilities of A and B, because we're going to add the area in the middle twice. But what we can do is take the probability of A and add the probability of B, and then remove the probability of the intersection because we've taken it twice. And that's really just it. So we take 0.55, we add 0.75, and we remove 0.55. 5, so that's gonna give us 0.8. And that's the result for A. Then for B, I see quite a lot of mistakes here, because people look up in the formula booklet that they want the probability of A complement intersect B complement. And if you look in the formula booklet, it says that if you want a probability of an intersection, then you can just take the two individual probabilities and multiply them. But if you look carefully, it also says that this is only when the two events are independent. In fact, this is the definition of it, what it means for events to be independent, and nobody has told us that these events are independent. In fact, we can show very clearly that they are not, because the result I'm going to get for this is not the same as multiplying the two complementary probabilities. But what you could do is go to your Venn diagram and imagine that if you take the complement of A, that means that you take everything outside A, and then you intersect with the complement of B. That means we take everything that is outside B. Then the stuff we get is the stuff that is both outside A and outside B. So it's the stuff out here. In fact, the probability of the complement of A intersected with the complement of B is the same as the probability of the union of A and B and the complement of that. And that is straightforward, because we just take 1 minus the probability of the union, which is the guy we just calculated. So it's going to be 1 minus 0.2, and that is 0. Oh, sorry. 1 minus 0.8, and that is 0.2. This is one of those cases where the word hence is a little bit of help, because if you're sitting and doing this and you realize that you're not using your result from the previous question, then you can be almost sure that you are taking a more difficult route, definitely, and maybe even a wrong route, like for instance multiplying the two complementary probabilities. When they say hence or otherwise, it is because there are other ways, but I can promise you that almost every single time using the result you just had before is the fastest way. Then we skip question 3 because it's a little bit tricky. We save that for the next video. But question 4 is a triangle, and we are given two side lengths. It's both in the written information up here, but it's also written on the drawing. And they are telling us what the cosine is of one of the angles. And they are sweet enough to show what angle it is, this BAC angle, meaning that we go from B to A to C, and the angle we make on that journey is the one that we're being told that the cosine of the angle is 1/5. So the most important thing to do here is something that you are supposed to not do, and that is to think that the angle up here is a right angle. It looks pretty close to 90 degrees, but you cannot be sure of that. We are not being told, and we are even being told that the diagram is not to scale as a warning. So that is an assumption you cannot make. In fact, when we get the result, if we did a little bit more work, we could also find the remaining angles, and we realize that this is not a right triangle. So they ask to find the area of the triangle. And you could, if you look at the drawing, what you should realize is we have a side length and a side length, and we know something about the angle between them. So if you want that related to the area, by far the fastest way is to remember this area formula for a triangle that says we take 1/2 times the AB side length times the AC side length And then we are going to need the sine of the angle between them. And that's a little bit annoying because we have the cosine of the angle between them. But then when you think about that, I have the cosine, I need the sine. You should instantly remember that the sine and the cosine for an angle, they're related, because we know that the sine of A squared plus the cosine of A squared always equals 1. And if we put in that we know the cosine is 1 over 5, then it says that sine of A squared is equal to 1 minus the square of the cosine, so that's 1 over 25. So we get, this is 25 over 25, so we get 24 over 25. And then we take a square root to get the sine. Here we should be a little bit careful, thinking what about the negative square root? But since we are in a triangle, then we know that the sine of any angle in a triangle is a positive number. So we know that we have to take the positive square root of 24 over 25. And square root of our fraction, we just do numerator and denominator separately, so we get square root of 24. And the square root of 25 is just 5. We can also do a little bit of this radical business, that 24, that is 4 times 6, and the square root of 4 is easy, so we get 2 square root of 6 divided by 5. And that's pretty nice, because if we do the area formula then, we put in the 1/2 times the length of AB, that's the square root of 6, times the length of AC, that's 10, and then we multiply with 2 times another square root of 6 over 5. So the 2's and the 1/2, they cancel out. The 10 and the 5, they become 2, and then the 2 square root of 6's, they multiply together, they become a 6. So that gives us a really nice result that the area is equal to 12. And that's a really good sign on paper 1 that you get nice integer results, because that tells you that you've probably done everything right. Now, that was it. It's been 12 minutes, and even with a lot of talking, we have enough marks by now to be sure that we are going to pass.